Okay, so we have an example here. A force of 100 Newton pushed a 5 kg block bin from bottom to top of 30 degrees inclined plane. Find kinetic energy, and also we need to find the final velocity. Okay, so the first thing we need to do in here is we need to find work. Remember, the block of this has been pushed upward, so the distance and the force are heading in the same direction. So remember, the angle between them is 0, so work will be FD cosine theta. Okay, and in that case, remember, theta is equal 0, so cosine 0 is 1, so work in this case is equal FD, so FD should equal 2000 joules. So we managed to find work for this block, which is equal to 2000 joules. Remember, the major equation here today that we need to look for is work equal potential energy plus kinetic energy plus energy lost. Now in that case, you have to understand that potential energy plus kinetic energy plus work friction, all three of them should equal work. So we know now work is equal 2000 joules. Let's go ahead and find the other part of the equation. It's possible now to find potential energy mgh, and mgh you should have 5 times 9.8 times 10, and this should equal 490 joule. All right, we managed to find work, and we managed to find kinetic energy of the system. Remember, it always has to do with height, potential energy. Second part of this, we need to find from our equation. Remember, this is the equation that we looked for. We already found work and we found potential energy, and now we need to find energy lost. Remember, energy lost defined as work friction, and work friction should equal F mu, which is force friction, times D times cosine 180. Why is it 180? Because remember, this block, if the distance heading this way, the friction is always acting the opposite way. So if the distance heading in this direction and the force friction is heading the opposite direction, the angle in between is 180 degrees. And if you need to calculate this, 100 cosine 180 is -1. So before we get into this, so we do understand that the cosine is 180 for work friction, but before we fill in this equation, we need to find force friction. Force friction, in this case, it's mg cosine theta mu. Let's find force of friction. Remember, force of friction is always the normal force times the friction term. So here you have mg. Remember, m is 5, 9.8, and then you have cosine 30 degrees. Remember, for force, you'll have to pick the angle on the inclined, not like the work. The work always take the difference between the distance and the force. It depends on the situation. But normally for force, you need to pick the angle of the inclined, and in that case, force of friction is mg cosine theta mu. So 5 times 9.8 cosine 30 times the friction, which is 0.2, and this is will end up having 8.5 Newton. So force friction is 8.5 Newton. Now we can go ahead and find work friction. So work friction will be force friction will be 8.5 times the distance, which is 20 times minus 1, and this will equal 100 minus 170 joules, and now we managed to find energy lost. Remember our equation, its work should equal PE plus KE, which is kinetic energy, plus energy lost. And again, we need to know that potential energy plus kinetic energy plus energy loss should equal work. And we already defined work as 2000 joules, kinetic energy as 490, and kinetic energy, it's still trying to find, potential energy is 490, plus energy lost, which is 170. In that case, kinetic energy will be equal 2000 minus 490 minus 170, and this will end up 1340 joule. Now I managed to find kinetic energy. So if you add kinetic energy and you add energy lost and you add potential energy, all three of them should equal 2000. Can we find the velocity, the final velocity? Yes, of course, because we know that kinetic energy is equal half mv square. This will lead to v square 2 kinetic energy over m. Will be v should equal square root of 2 ke over m, and the answer is 23 meters per second square.